Do you remember the first time you saw the Terminator movie? And seeing future world where humanoid robots rise to the top on an intellectual level? Well, it would seem that such advancements in the field of robotics has led us to a crossover point, with startup companies all around the world fighting to build the ultimate humanoid robots. So sit back and relax as we take a look at the 7 humanoid robots, which are being integrated into our everyday lives. Sophia was first activated on February 14, 2016. The robot, modeled after the ancient Egyptian Queen Nefertiti. As of 2018, Sophia's architecture includes scripting software, a chat system, and OpenCog, an AI system designed for general reasoning. Sophia imitates human gestures and facial expressions and is able to answer certain questions, to make simple conversations on predefined topics. Sophia uses speech recognition technology from Google's parent company Alphabet Incorporated. Her speech synthesis ability is provided by Cereprox's text-to-speech engine, and also allows her to sing. Sophia's software is designed by Hanson Robotics. This is THR3 by Toyota. HR3 reflects Toyota's broad-based exploration of how advanced technologies can help to meet people's unique mobility needs. THR3 represents an evolution from previous generation instrument-playing humanoid robots, which were created to test the precise positioning of joints and pre-programmed movements, to a platform with capabilities that can safely assist humans in a variety of settings, such as the home, medical facilities, construction sites, disaster-stricken areas, and even outer space. The partner robot team members are committed to using the technology in THR3 to develop friendly and helpful robots that coexist with humans and assist them in their daily lives. People all around the world adore Osimo, the advanced humanoid robot designed to someday assist people in their daily lives. Osimo plays a valuable role globally in encouraging and inspiring young people who are interested in careers in STEM, science, technology, engineering, and math. Osimo, whose name is an acronym, was first dreamed up way back in 1986. Osimo made its US debut February 14, 2002, when it rang the opening bell at the New York Stock Exchange. Since then, Osimo has undergone many refinements, as Honda continues to advance the robot's capabilities. Today, Osimo continues to travel the globe to amaze and delight people of all ages. And yet another one by Toyota. Do you see the trend? Is Q, the robotic basketball player. For those unfamiliar, the Q3 was first unveiled 2 years ago, where it sunk over 2,000 free throws in a row and 5 of 8 3-pointers. While it can't dribble or jump, the 6-foot 10-inch tall robot wowed spectators as it scored a free throw, a 3-pointer. The Q most likely won't be replacing NBA players anytime soon, but watching this strange-looking robot pick up a basketball from half-court, calculating the perfect arch, then scoring a half-court shot, is a sight to behold. Q utilizes sensors in its torso to calculate the exact distance from the hoop, to make those shots. It uses this information to determine the best angle. This is GPR-1. It's a general-purpose robotic avatar, designed to help its human pilot accomplish a diverse range of tasks. Sanctuary's mission is to democratize work, with labor-as-a-service general-purpose robotic avatars, making it possible for anyone to do any job from anywhere and at any time they choose. We are making work safer, more accessible, and ultimately more productive. Using cutting-edge technology and artificial intelligence, cognition, and robotics, the startup company are delivering immediate customer value with labor as a service. From agriculture to energy, healthcare to logistics, retail to construction, and everything in between, on this planet or any other planet, the possibilities are literally out of this world. During the pandemic, many businesses were forced to stretch their existing workforces to breaking point in order to meet demands, which is where agility robotics come in. With Digit, our latest product addresses the mobility limitations of traditional robots, so that machines can work in environments designed for humans. Digit features robust walking and running gaits, perception to enable stair climbing, and autonomous navigation in unstructured environments, and arms for basic manipulation tasks. Major features include upper torso with integrated sensing, computing, and 2 forward-doof arms, extra bay for additional computing and custom payload integration, sealed joints for all-weather outdoor operations, UN 38.3 certified battery for cargo air shipments, comprehensive software API that leverages our controls, perception and autonomy algorithms to develop end-user applications, low-level API for customers wanting to develop their own controller. These are just a few of Digit's groundbreaking capabilities. Digit has been commercially available and shipping to customers since July 2020. On September 1st, Albany, Oregon-based Agility announced that it had raised a total of $28 million in funding thus far. And a website for Digit claims that the product was designed to address the mobility limitations of traditional robots, so that machines can work in environments designed for humans. In this video, Digit can be seen using autonomous navigation in a warehouse-type environment, using its tiny dinosaur arms to grab boxes and then trot them across the room. Damian Shelton, CEO of Agility Robotics, said the brand's technology was designed to fill in the gaps of a human workforce, not replace it.
$1 million investment round, led by DCVC and Playground Global, among others, to build a really excellent consortium of investors. And that's going to let us really get our Digit robots into customers' hands, doing useful work in the world. Industrial robots are designed to do one task over and over and over, and to do it well, you design the whole process around the robot and the whole environment around the robot. But there's always going to be spaces and jobs that are designed around humans, designed around us, because this is our world. If robots are going to be effective and useful to us, they're going to have to work on our terms, in our space. Having Digit work in human spaces means Digit is going to be able to do a wide variety of different tasks. Things like package handling in warehouses, or indoor and outdoor delivery.
The suggestion to replace employees doesn't make sense. What makes sense is leveraging technology to supplement, or augment, a human workforce, Shelton said. Doing so does two things: it helps companies meet customer demand, and it frees the human workforce into jobs that require decision-making, creativity, and collaboration. The company sees Digit's value as a more plug-and-play solution than something like Berkshire Gray's offerings, which builds a fully automated warehouse from the ground up. There's still programming involved, of course. An Agility rep will appear on site to pre-map a location and help the robot execute its repetitive tasks. Agility hasn't announced partners beyond Ford, though it says it's currently working with major logistics companies. It hasn't revealed numbers of Digits sold either, though it tells TechCrunch that the number is substantially more than the dozen chassis units it sold prior to Digit, largely for research purposes. We've grown pretty rapidly since last December, says Shelton. We're expanding our Pittsburgh office by the end of the year, in addition to the Oregon office. We have a pretty rapid growth rate, as we've been increasing the production rate on the robots. So guys, don't be surprised when you see Digit turn up at your work. The change is coming. The future is now. And in today's one, we take a look at the fascinating science behind Atlas from Boston Dynamics. Atlas is the most dynamic humanoid robot currently on the market. Its state-of-the-art hardware gives the robot the power and balance to demonstrate human-level agility. The robot has one of the world's most compact mobile hydraulic systems. The custom battery, valves, and a compact hydraulic power unit enable Atlas to deliver high power to any of its 28 hydraulic joints for impressive feats of mobility. Atlas's advanced control system enables highly diverse and agile locomotion, while algorithms reason through complex dynamic interactions involving the whole body and environment to plan movements. The robot uses 3D printed parts to give it the strength-to-weight ratio necessary for leaps and somersaults. By training Atlas to maneuver its way through complex parkour courses, Boston Dynamics engineers develop new movements inspired by human behaviors and push the humanoid robot to its limits. Let's take a look at how Boston Dynamics are building a foundation with Atlas. A robot's ability to complete a backflip may never prove useful in a commercial setting. But it doesn't take a great deal of imagination or sector-specific knowledge to see why it would be helpful for Atlas to be able to perform the same range of movements. If robots can eventually respond to their environments with the same level of dexterity as the average adult human, the range of potential applications will be practically limitless. Humanoids are interesting from a couple perspectives, Koindersma says. First, they capture our vision of a go-anywhere, do-anything robot of the future. They may not be the best design for any particular task, but if you wanted to build one platform that could perform a wide variety of physical tasks, we already know that a human form factor is capable of doing that. From a technical perspective, humanoids present several challenges that we welcome as a research team, he adds. Their combination of size and complexity creates hardware design trade-offs related to strength-to-weight ratio, runtime, range of motion, and physical robustness. At the same time, our control team has to create algorithms that can reason about the physical complexity of these machines to create a broad set of high energy and coordinated behavior. Ultimately, pushing the limits on a humanoid robot like Atlas drives hardware and software innovation that translates to all of our robots at Boston Dynamics. Parkour, as narrow and specific as it may seem, gives the Atlas team a perfect sandbox to experiment with new behaviors. It's a whole body activity that requires Atlas to maintain its balance in different situations. It's really about creating behaviors at the limits of the robot's capabilities, and getting them all to work together in a flexible control system, Koindersma says. There are many important problems that parkour doesn't force you to address, but that's not the point. We're not trying to solve everything all at once. The work we're doing now is allowing us to create a solid foundation. Looking back over 5 years of Atlas videos, it's easy to lose sight of just how much progress the team has made during that time. In fact, some of the improvements are invisible to the average viewer, even though they represent giant leaps in technology. Atlas's moves are driven by perception now, and they weren't back then, Koindersma explains. For example, the previous floor routine and dance videos were about capturing our ability to create a variety of dynamic moves and chain them together into a routine that we could run over and over again. In that case, the robot's control system still has to make lots of critical adjustments on the fly to maintain balance and posture goals. In this iteration of parkour, the robot is adapting behaviors in its repertoire based on what it sees. This means the engineers don't need to pre-program jumping motions for all possible platforms and gaps the robot might encounter. Instead, the team creates a smaller number of template behaviors that can be matched to the environment and executed online. Simulation is an essential development tool for the Atlas controls team, both for evaluating new behaviors prior to robot testing and for ensuring that new software changes don't negatively impact existing capabilities. But there's still no replacement for hardware testing, particularly in performance-limiting motions like vaulting. About that vault. Unlike high-flipping gymnastics vaults, a parkour vault is a slightly less flashy method, designed to get a runner over a low wall or obstacle. In this case, the balance beam, only a few feet high. Atlas places its arm on the beam and then hoists its body over the structure. For many humans, this sort of vault would be relatively easy. But for the Atlas team, it represented a formidable new challenge. If you or I were to vault over a barrier, we would take advantage of certain properties of our bodies that would not translate to the robot, Koindersma notes. For example, the robot has no spine or shoulder blades, so it doesn't have the same range of motion that you or I do. So guys, I hope that demonstrations like this provide a small glimpse of what's possible. So where do you see the future of Atlas? A robot for show or a marketable product adopted by humanity? Please leave your opinions in the comments and have a good day.